Okay, what I want to talk about today is something that's sort of like near and dear to me. So, currently I'm at Uber's Advanced Technology Center, and one of the things I worry heavily about is whether we're building the right software in order to do all the crazy things that we might be up to, and how that actually translates to the team that we're building at the same time. So, once upon a time, I used to be a developer. I think someone was making a comment recently, like, we're talking about the parallel tracks of management and engineers when it comes to like the big companies, like, Google, Facebook, Twitter, Uber has parallel tracks of engineering and management. And they were asking me, like, if I were to go back to the engineering ladder, would I stay at the same level? And I was like, fuck no. Like, I don't remember the last time I wrote code like that looked like that, but that was kind of my job when I first joined Twitter. And what I've been more interested in toward the end of my Twitter career and things like that was the question of speed. And what I mean by speed is not speed of software, but more the speed at which we can write software. How many of you have experienced time dilation? And what I mean by that, before I sort of like go into like the relativistic definition, is more this like, when you're at the beginning of a project, you're kind of rocking and rolling, right? Like your 2-week sprints, you're getting a lot of crap done. But as time moves on, like you feel like you're getting less and less done in every single one of your sprints. You're just sort of like everything is slowing to a crawl. Everything is taking longer than you think it should. Everyone is riding your back because they're trying to understand why aren't things as fast as they used to be when we started this thing. This showed up a lot at my last job, where I was the VP of platform engineering. Last job. So my tenure at Twitter started in 2009 when we had about 50 people in the office. So I was hired as a developer on what we call the platform team back then. So I'm personally the guy who wrote a lot of the geolocation APIs, like when you could first attach a latitude and longitude to a tweet. You can blame me. I'm the guy who wrote a lot of the original, like one of my first big projects was trying to figure out how to get all the tweets out of a single MySQL table, which was the architecture back in 2009. That was fun. And then so my tenure at Twitter ended sometime around 2014 when I retired after the World Cup that year. We had about 3,000 people working at Twitter at the time, and my team alone was about 450 people working worldwide. So the platform engineering team was in charge of the performance, the latency, the global distribution, the cost effectiveness of the Twitter platform, as well as making it possible for Twitter to launch new features really quickly. So we were trying to get everything in place so that Twitter can move really fast and not cost a lot of money in the process of doing it. And in this case, fast means both developing code at really large scale really quickly, but also fast when it comes to end users. Like, I could talk a lot about how to set up a region-specific CDN, say maybe in Brazil in time for the World Cup, to make tweets go really fast in certain portions of the world. So a lot of my work back at Twitter was around that. These days, I'm focused at the Uber Advanced Technology Center, where we're working on things broadly around mapping, safety, and autonomy. You might ask what that means. And it usually means working on things that look like this when it comes to the vehicles that we're building in Pittsburgh. So in what I worry about here at Uber is, again, a lot about speed. The competition when it comes to cars that look like this is really hot. People have a large head starts in front of us, and we're trying to catch up really fast. So whatever we need to do in order to get our team in place so we can pull that off is something I'm really interested in. So, I get asked a lot around questions of like, how do I make my team go faster? How do I fix certain problems I'm having in our stack and things like that? And it usually comes down to people asking me questions when things look like this. Like, everything is not fine. And it's when people come and ask me, like, how can I make things go better? Or thankfully, or frankly, when people feel like they're in this situation, which is just like racing toward the cliff, at least people see the cliff in this situation, is when they come and ask for help from me. But the things I get worried about is when you get graphs that look like that, which might look fine. This is actually semi-real data from back when I was Twitter. But the thing that's missing in a graph like this is that it's actually being clipped. So the architecture or your team is not set up to understand when you're not really servicing what your customers need at the time. So, like I mentioned before, speed is the thing I'm really curious about. Like, how do you make sure that things don't take longer than you think? How do you make sure things aren't harder than you think? And how do you make sure that one change doesn't have like this cascading effect through everything else? So the first thing that most people sort of come to me when they ask for help is they hear this phrase a lot from their management team, which I hate, because I sort of hate the day when the management team understands the word velocity, because then it just gets thrown around in every single context and demand. But it's also when their engineering team says things like that, that sort of my eyebrows sort of get raised, because I'm one of those managers who really tries to make sure the team is driving a lot of the decisions. So when the team is sort of yelling at me that the code looks like crap, you have to really wonder what's going on behind the scenes. So the first thing that an org usually does that I think is horrendous is they go and embark on the massive rewrite in order to try to fix this problem. So, it's been years since we listened to Joel on software, but this quote really resonates with me from Joel, so I'll give you a second to read it. So we've hired some of the best, or we think we are some of the best engineers in the world, and our first natural instinct usually is to tear all that stuff down. I'm just going to build it again. I can do better than the last guy. It's much easier than anyone thinks. This is like the #1 fallacy that I sort of run into every single time when I talk to engineering teams. First problem is that most times a lot of people don't manage what we call technical debt correctly. So this is one of my favorite quotes when it comes to technical debt. Another good one that shows up a lot. Another good one which shows up a lot when you look are things that look like this. So technical debt management is usually one of the biggest problems that we face when we're trying to go through a lot of our projects, right? So like rewriting it, I'm going to argue, is not necessarily the best way forward. Because in most cases, when you try to rewrite it, the business stays still or it moves on. Both of these are horrendous. So like in Twitter, we experienced this. So I started the massive rewrite of the Twitter architecture in 2010. I claimed we'd be done in 3 months. Thankfully, I didn't get fired a year later when we still weren't done yet. But sadly, Twitter stayed still. Like, I'm not sure how many of you very carefully follow the history of Twitter, but in 2010, basically Twitter shipped 0 new features. Midway through 2011, Twitter still had shipped basically 0 new features. Finally, when we were done, we started launching things like photos, advanced direct messages, and things like that. So like basically, we halted the business for 1 year. That's horrendous. That's what happens when you sort of like when you listen to your org and you say like, we need to rewrite this thing. That's one of the horrendous things that happens. The alternative is the business moves on, and that's also full of crap because it means that you're forever in catch-up mode. Like the business is doing all these crazy things as the infrastructure guys effectively are trying to catch up or trying to keep up to date. That also truly sucks. You feel like you're always in a losing battle. Second thing that goes wrong is that you have less time to actually re-implement everything than you really think. And what I mean by that is like it took you 2 years to write this software, for example. Now everyone's going to ask you to rewrite it in 6 months. That doesn't even pass a giggle test in a lot of ways. So like you're going to be under massive time pressure, and your org is just not going to survive that one very well. You're going to have attrition sort of going through that kind of situation. And finally, you're going to get in a place, and honestly, I'll tell you a war story of Twitter in 1 second. You can't turn off the old system until you're basically 100% parity. So in 2010, Twitter was the world's largest Ruby on Rails site on the planet. In 2014, we probably still were. And that's after we still did massive re-architectures, pulled large amounts of traffic off the Ruby stack, build up huge Scala frameworks. We couldn't turn off the Ruby stack. And because Twitter is still growing really fast, the Ruby stack, even though it's taking less than 15% of traffic, let's say, still turns out to be the largest Ruby stack on the planet. So you can't, it's also a never-ending and never-winnable battle in a lot of ways. You're kind of like in the Kobayashi Maru situation. So all rewrites sort of go through the same 5 steps, I find. One, you have like the elation of the team where you're just like, yes, finally we get to throw out that crappy code and we get to start over and we get to do it the right way. Then the second stage that your team normally gets into is like the buckle down stage, which is just like, there's a lot of work here. We really underestimated scoping this project before we decided to start this massive rewrite. Third stage is the oh shit stage, which is just like, holy crap, there's a lot of work here. This is never actually going to go finish. The fourth one is the one I've experienced many times, which is pure exhaustion when it's 1 year later and you promised it'd be done in 3 months. And then finally, you sort of get like to the release stage, which is generally caveated with phrases like, we had to cut lots of corners to get this out the door. We'll get it right next time we rewrite this thing. Like it just sort of compounds upon itself. So basically what I'm really trying to say is like the rewrite, which is the first instinctual thing for your team to try to go do, is probably going to destroy you. It's going to kill your software in the process. The thing that almost no one takes into account, though, when you're really trying to look at these big sweeping projects is, do you even have the right team to go do it? And I don't necessarily mean the right developers. We can argue all day long whether you've hired the right people, whether you have the right kind of like bar that you're passing, whether you lowered the bar, you've raised the bar. I'm actually talking about how you've structured your team in order to pull off something as big as this. So let me make this a little more concrete. Let's talk about compilers for 1 second. So this is ESR. First this is Conway's law first, which is basically the underlying theory of how software teams basically get organized. I'll give you a chance to read that. I'll delve into this more in detail in a second. So let me make this concrete. Sounds about right. Or we can tell a joke about this too, I suppose. So let's say you have a database expert, C# expert, and JS expert. You will end up with a 3-tier architecture in your software. Let's say we killed the C# guy for a second. All of a sudden, you have a Node.js architecture. So like you will find out that however you set up your team is going to have this massive massive implication on your software architecture in the end run. So let me step back for a second. Let me talk about robotics for a quick second. So robotics has this standard loop, which is kind of like the perceive loop, the think loop, and sort of like the action loop. So like you have to understand the world, you think about the world for a second, and then you make a movement in the world. So it turns out a lot of robotics teams are set up that way. You have a team which does perception, you have a team which does basically prediction and planning, and you have a team which does motion. And then it sort of like cycles back again. So you can think of a robot basically doing just that. Like it sees the microphone, it thinks about how I need to get my hand there, and then it moves the hand slowly there, and at some time increment, it does this over and over and over again. I would argue this is not necessarily the way you want to go look at this particular problem for this exact reason. Like maybe there's a better architecture that you want to go and chase there. Maybe there's a more generalized way, or perhaps you want to actually go at it like at a feature-based level. Like the feature I'm trying to attack is like I need to go reach this. So like we'll make one full stack team that's sort of around that. I wish I could talk very much in detail about how we're attacking those type of problems at the ATC. Talk to me in 10 years, and then I'll show you the kind of things that we did behind the scenes to get there. So instead, what I'll do is I'll talk about it from the Twitter domain for a few minutes. So when I started at Twitter, the architecture of the site was looking basically like this. We had one huge MySQL database, and we had one monolithic Ruby on Rails system. Throw some caching in there, throw some other nice accoutrement, basically, to make this thing work. And that's basically what our system looked like. In fact, our team looked like this too. We basically had a bunch of DBAs, and we had a whole bunch of people who wrote the infrastructure of Twitter. This wasn't scaling. This was falling over. It was also leading into really bad developmental dynamics in the team. So for example, one single Japanese translation actually took down the site for a day. It took us a day to figure out exactly what went wrong. Like, you have whole situations of no one's actually an expert on anything when it comes to a system like this. So when someone makes one small change, A, the expectation is that they would understand everything that could possibly go wrong, which is crazy. And then B, that someone might be able to diagnose it quickly because they might be an expert on, say, tweets, but no one actually is in this scenario. So I spent 2 years sort of working with the team, making the architecture look something more like this. It looks like spaghetti. I'll get to that in a second. But basically what we did is we created microservices for Twitter at the time. This was in 2010. This was before the term microservices was mostly the fad it is today. We called this more a service-oriented architecture. And Netflix has been touting this a lot recently with a bunch of these type of pros and cons list. So, while in the monolithic architecture, you have a lot of advantages because it's easy to scale horizontally, everything's kind of in memory. In the microservices architecture, you get to this place where every single thing is responsible for a small piece of the site and a small part of making things actually actionable toward the end. Okay, but what does this mean for the team? So for a biology reference for a quick second, if you're trying to build something flexible, you're probably going to build something complex, in my opinion. So instead, what you should think about is simplicity. Because when you have something that's simple, it's easy to understand, it's easy to build upon. And when you have something that's complex, it's really hard to make sense of what's really going on. Sadly, complexity and flexibility are probably really closely interlinked. And that's something I want you to keep in mind for a second as I go back to this. So on the right-hand side, if you try to make that architecture flexible, you're going to make it really complicated in the process. So if you're trying to make it easy for anyone to add anything they want to that single monolithic piece of code, you're probably going to make it overly complicated to pull it off. The nice thing about what's going on the left is that each one of those is really simple. Each one of those is easy to grok. Each one of those is easy for a single team to wrap their heads around, and you can move really, really fast in that world. So I'll go more into detail, but setting up your team says more about the architecture than the architecture itself in the grand scheme of things. So what Conway's law would say is that your team, the way you set up your team dictates the way you write your software. And then what I'm going to say is the way you write your software is also going to dictate your team. You got to figure out how to manage that loop that goes round and round and round. So just having a team of, for example, going back to our Node.js example, having a team of 3 developers will fundamentally give you something different than having a team of 2 developers in the end. So here are some cartoons that might sort of explain this for a second. So this is a caricature of what the Amazon organization might end up looking like. For those of you who've worked at Google, this might kind of make sense. For those of you who've worked at Facebook. My favorite is sort of when you get into Apple. Microsoft is pretty entertaining too. And then it turns out Oracle's not even an engineering team in the grand scheme of things. So, but just by that laughter, you could sort of understand that each one of those team dynamics has set up what we think of as how their system runs. So let's take Microsoft, for example. Microsoft is renowned for running teams against each other effectively. 2 different teams going after the same problem, tried in 2 different ways. But I would say, sadly, this ends up showing itself in a bunch of the products they end up building. Like none of their products interoperate until recently. None of their products interoperate really well because they're basically warring faction teams in some way. Google instead has like this crazy dynamic where every single thing is interlinked to every other thing. And honestly, it all kind of looks like crap in the end. Like you can make an argument that like none of Google's products are as polished as, say, the Apple set of products that has their single product dictator calling every single shot. Google's are much more done by consensus, for example. So each one of these gets codified in the way that they run their products and the way that their products get developed. So how does it apply to this picture? So back in the day, this was one single team, maybe 2 when you actually slice up the DBAs. Each, as I was saying before, every single person on the team basically was an expert at nothing. Everyone needs to understand every single piece of the software in some way, shape, or form, which means that like if you had a question of how to extend tweets, for example, how should I add a latitude and longitude to every single tweet we wanted to put into the table, no one person had the answer. In fact, what you had is more like 30 opinions on how this could possibly be done, but no way to make really fast progress to get that done. So you can't build one team that ends up managing this. What you end up there instead is having to figure out how to make smaller teams, each one with a single responsibility. So for example, that first one I circled is a TFE team. They're basically at Twitter, they're the layer 7 load balancer that handles all of traffic that goes into Twitter. That's all they do. They are world experts on how to manage global traffic coming into the Twitter data centers and routing it to wherever it needs to go. That second team, sorry, which team? I can't even tell for sure. It's the web team. They're the team that knows absolutely everything that needs to be done in order to make the Twitter website functional, efficient, and actually easy to develop in. So having these small teams, these small restricted constraints, really means that these teams can operate really fast and really well together. And in fact, we can sort of keep on going. Like I had one team that all they did was know everything about tweets. In fact, when you wanted to add pictures to tweets, this is the one team that you had to go talk to pull it off. One team that handled the social database. So having these many smaller, clearly smoked teams and having clear ownership for each one of these teams allowed the org to move a lot faster again. In fact, this is the way that Twitter gets to about 100 deploys a day, is that you have all these really, really small teams that can move as independently as possible, not interlinked with each other. I'm sort of like preaching to a bunch of software engineers who have seen this on the software end of the world, but I'm saying taking this to your teams in some ways allows your teams to move really fast and move really independently. You can get the same benefits that microservices gave you for your software on the team level as well. So the gotcha, though, is that each one of these small teams could potentially explode in sort of the complexity you want to go do. So what I would suggest to do to avoid this is that you want to start with really small teams and try not to overstaff them. Like it actually turns out really small teams can get a lot done when you sort of let them run. And I would try to staff each one of these small teams with as broad of an experience as possible. I think what a lot of people end up doing is, for example, taking the web team and staffing it with some of the world's best web experts and saying, go build us a website. The problem with that is that you end up with like 50 different web frameworks all packed into your software. That may not be the problem, but it's ununderstandable to anyone who's not a web developer. So what you really want to do is, no matter what the domain, figure out how to staff generalists onto this team, or figure out how to staff multiple experience domains onto the team itself. So for example, on the web team that I ended up running at some point, I had both JS experts, Ruby experts, Scala experts, and database people on the web team, not just like isolating the database guys to a database side, because it really meant that they thought about the architecture in its fullest and not ended up with some crazy single-purpose decisions. For example, the database team, the storage team at Twitter, had front-end engineers on it. They provided perspective on what everyone else might need, but it also meant that the database team built really gorgeous tools that everyone in the company could end up using. In fact, like we had some of the best, in my opinion, one-button storage deployment mechanisms that I've ever seen in my career because we put front-end engineers onto the storage team. So you get some of these side benefits by really mixing it up, even on the smaller levels. So I would say that you don't want to work against the grain, you want to work with the grain. So if this is the architecture that you want to kind of do, I would say go build your team that looks like the architecture you want to go do. And then let these individual teams run as fast as they can to really tackle all those individual problems to make them go as you want, and keep these teams really small and nimble in the process. So sort of taking Conway's law for a second and sort of Yodaizing it, like what you really want to go do is design a structure that produces the system you want in a lot of ways. Like you want to go build the team that builds the software that you want it to look like. So the one other problem that comes up a lot when organizations are trying to build software correctly is that they try to reach consensus all the time. So we've talked about rewrites, we've talked about team structure, and then once you have all these really small teams, they try to reach consensus really fast, and they try to make sure that everyone is sort of happy. And it's sort of the caricature that I like to put up when someone proposes that is sort of this one, which is sort of like, you know, this is a horse that was designed by a committee in some way. It doesn't fit anyone's purpose really well, except maybe the camels who's trying to survive in the desert. But it doesn't serve anyone's purpose really well. What you really want is to figure out how to make product a dictatorship. So if you look at a graph that's like basically the number of people that you have making decisions on your team, and you look at the kind of product you build or the software architecture you're kind of building, the graph ends up looking kind of like that as you sort of throw more decision makers at it. This is the classic too many chiefs and not enough Indians problems in a way. And what I would suggest is sort of like by the author of The Little Prince is you know when you've reached perfection in design, when you have nothing more to take away from it in a lot of ways. Sort of chasing simplicity in a lot of ways is the only way to go build it. So how do you do that when you have a large number of teams? The only way to go do that, again, is to make product a dictatorship. So let me give you a very technical example of how this is a massive failure. So asynchronous mode transfer networking. This is the networking standards of the 80s and 90s. So, you know, this is basically the 3 lowest layers of the ISO model, the physical and data network. It's basically switching. This is before packets and stuff like that. And the argument is between the Americans and the Europeans. The Americans, we have faster networks. We want to shove more data onto the networks. We want 64-byte headers on everything. Europeans, slower networks, really concerned about latency because they want to route voice over their networks in the 80s and 90s, want smaller packets. So what you do, you get a committee of people together, try to sort this all out, and the answer that you come up with is you make a 48-byte packet. And that's like exactly the wrong thing. It suits no one's purposes when you're trying to make this work. In fact, you've basically equally pissed off everybody as opposed to making any single purpose happier. And this is the problem you get into when you try to make product in your organization a consensus mechanism, is that you basically build the lowest common denominator, which is shit for half the people who want to go use your product. So product needs to be a dictatorship in order for this to be successful. You have to have a single way to make a call. So, okay, so recapping so far. Rewrites are bad. That's the first instinctual thing for your organizations to try to do. Your second one is make sure you set up your team correctly in order to even try to tackle the problem you're doing. Whatever software you're trying to write will end up mimicking the way that your team is set up. So be thoughtful about that. Set up some kind of dictatorship when it comes to the product in a lot of ways. Make sure you have actually clear decision makers. And the last one that I'll throw up is sort of be incremental in the process. So I think a lot of people, when they come ask me about those first 3, they're like, okay, I'm gonna try this all tomorrow. We're gonna kill all the rewrites, we're gonna reorg my team, I'm gonna set up a massive product owner. And my argument against that is like, you have to be incremental. Things will change all the time. So as my aside, this is my favorite counterexample to incrementalism. This is the Saturn V rocket. This is the rocket that was used to lift people up into the moon. John F. Kennedy really wanted to get people onto the moon by the end of the decade. This is the 60s. And it turned out when you work the Gantt schedule, which is an invention of NASA in a lot of ways, when you work the Gantt chart, if you did incremental testing on the Saturn V, they would run out of time. It would take longer than the 60s in order to pull this off. So what did German engineers do, because we got a bunch of Germans to work on this project, is they put the entire Saturn V together for the first time and they decided to light the thing up and see whether it'll take off. Yeah, those nervous chuckles in the room is exactly what I would say. Being a software engineer, you're like, that never works. That is like the worst idea I've ever heard of. It worked for the Saturn V rocket. The thing went off without a hitch. It took off for the first time they've ever put it together. The thing blasted off into space. You are not German engineers. You will never be able to pull off something as complex as that. I view this as a statistical fluke in the history of mankind. You need to think about how to be much more incremental when putting together both your architecture and your organization. Things will change all the time. So I want you to think about, again, when you're going through no more rewrites, setting up your org, getting up a product dictatorship in place, I want you to think about how to move slowly and try to figure out whether you're making progress before you just throw it all together and kind of see what happens toward the end. Okay. That's kind of all I had to say on this topic. So just sort of like recapping quickly, make sure your teams mimic your architecture. Small teams can do a lot. Like I really stress having slightly understaffed teams because that sort of breeds creativity and you're not just inventing more work. Think about the compiler example. Do you need a 4-pass compiler or do you need a 3-pass compiler? It's purely dictated by a number of people you're gonna throw at that problem. Make product a dictatorship, have a single person that makes these type of calls in order to be able to move things forward really quickly. Be incremental, but finally, the thing that I want you all to remember, we're all developers in a lot of ways, but it's not just about the code. Like I thought it was all just about the code until I was fortunate to try to solve a bunch of Twitter's problems, and it's not about the code. It's really about the team you set up in order to tackle the problem. The code is just a byproduct of what the team is sort of building. Okay, so on that, I'm happy to entertain questions for as long as you guys want me.
Sorry, just raise your hand and we'll come over with a mic.
With the don't rewrite, would you say Twitter would be better if everything was still fully on Ruby on Rails, or would you find a more incremental way to switch off of that?
So, okay, so let me give you some backstory on that question. So the reason why the reason why Twitter effectively chose Scala as the answer to a lot of its problems was that there was a bunch of more old school enterprise people like me who joined the team who believed in the JVM heavily. Just many more people have worked on the JVMs, been deployed at a larger scale, stuff like that. And then B, Scala kind of looked like Ruby if you squinted really hard. So you got a best of both worlds in that situation. If I were to do it again, say like if I were faced with the exact same choice today, knowing what I knew back then, I probably wouldn't have gone down the same path. However, technology has also changed in the process, right? So like Java's Lambdas sort of take care of most of what people wanted Scala for. It turns out the Ruby VM has gotten a lot better. Turns out a lot of people have done a lot of work on how to do microservices in Ruby. So I think we would have evaluated all this and sort of like ended up probably still in the microservices world, but I can't guarantee we would end up in the Scala world. The question is like, would Twitter end up be better or worse if we stuck with the Ruby model? It's also just an unknowable question in some way. But I think I would have tried to figure out a more incremental way to bring microservices into play. So that 1 year that it took in order to get the site rebooted was because we tried to reboot the entire site. Like we wrote a new tweet service, we wrote a timeline service, we wrote a user service, we built all these big pieces of technology and tried to launch them all. Maybe the right thing to do would have been to just launch the tweet service first and sort of like wire that into the Ruby code base and then build a timeline service next and wire that into the Ruby code base. So that's what I mean by at least try to be incremental in the process. So maybe that's what I would try to do differently next time.
Hi, thank you for sharing your experience with us. So you spoke about teams and making them smaller, and we have a team of 15 people, and 4 of them are on advanced initiatives or sort of, that team, which leaves 11 people, and so that's not really enough to do sort of break out into the teams that would represent our services, our components. And so I wonder 2 questions: what do you think about smaller teams breaking out into, or smaller groups breaking out into teams? And second, what do you think about advanced initiatives teams being separate from the team?
I'll answer for, okay. So I do think 11 people is small to try to break them up into like really firewalled off teams. I think shared, like having clear owners and then maybe Gaussians of responsibility is what I would at least try. So at least there's at least a set of people, like you are clearly responsible for this, you're clearly responsible for that, and there's some bleed over is one thing I would necessarily try. I do think that I talk to a lot of people who try to set up very large, complex microservices like architectures with small teams, and I try to shy them away from that in a lot of ways. I do think that the number of things that a person can hold in their head is like what, 7 plus or minus 2? So I would try to make sure that that magic number is sort of maintained when you have the number of people on the team in some way. So that's that. So an advanced initiative team, so the reason I chuckle for a second is because this is effectively what Uber is doing. So Uber is let's call it a 1,500 person engineering organization globally, and then we have N number of people, which I won't say exactly how much, working on the Advanced Technology Center, where I am, working on basically the future of the stuff we're doing. The reason why it's set up that way is so that we can effectively firewall off the team. Like teams are on 2 different shipping schedules. The team that works on Uber, the application, ships really fast. Like they are the ones that do tens, if not hundreds of deploys a day. The team that works at Advanced Technology Center want to be shipping really fast, but give us a couple years before we get there. So just understanding there's just even a complete impedance mismatch between those 2 things is one of the main reasons that we're set up this way. So I would ask you that kind of question. It's just what are the characteristics of advanced, whatever you called it, versus the current day? Can they really coexist and mesh? And do you need to sort of firewall off in some way? One thing that we found in the Twitter rewrite, for example, is that we were trying to hold off people from jumping ship from the old system to the new system until we were ready. Because the developers, like all of us, want to work on the new and shiny stuff. So they want to jump over to the new stuff, and no one's minding the house on the older stuff anymore. So one of the reasons we set up the rewrite the way we did was to firewall off, make sure someone is running the ship while we try to get the new stuff up to date. Now, there's a morale problem that shows up with that. So the way we did that was try to make them included at least in design decisions, make them included in telling us the lessons they've learned so we can make sure we can account for it and things like this. So they felt bought in to the new future. But it's rough. Having these 2 separate teams, one working in new shiny and one working in current, is rough in a lot of ways. Again, Uber manages to pull this off by just literally physically dispersing the teams. Advanced Technologies in Pittsburgh, Uber headquarters is in San Francisco. So no one's just walking across the block to see exactly what's going on. So that's the way we manage it.
So when you divide into small specialized teams, humans are really good at dividing into tribes and fighting against each other. How do you keep the web team from hating those darn database guys and et cetera?
Generalized teams is the only way to go do it, in my opinion. So I lived this. So my first incarnation of breaking into specialized teams was to put all the JS people basically on the web, put all the DB people on the DB, put all the infrastructure people on the big services and things like that. And you often, it would often get escalated to me as the VP of just the JavaScript guys are morons, or the database, what are they doing? And one, I am not qualified to make the call of who's smarter than who. But two, like this is just not a fruitful conversation to have. So one of my comments earlier was that you need to set up full stack teams no matter where you put them, so that the web team, for example, is not just a bunch of JS people. Like there are infrastructure guys and there are database guys on it. My database team had front-end engineers on it. And that sort of like allowed for making sure that everyone is sort of accounted for and thinking about our architecture, not product. And then B, it allowed for like interesting back channel conversations, right? So like the JS guys would be like, what are the database guys up to? And then the front end guys on the database team could actually explain it in a way that would make sense. So like it allowed for that kind of back channel conversation to happen. So you're right, people like to form into tribes. I would say you need to force them into tribes that's around the thing you're trying to build, not tribes of their skill sets in a lot of ways.
Okay. Hello. When you have all these small teams, how do you avoid having a lot of code duplication or a lot of different processes and tools? Because you're asking them to develop, test, move things to production, deploy. So how do you get some good practices and have everybody standardize on those same practices?
Yeah, so the way that I like to think about it is, you know, at Twitter, and we do the same thing at ETC, is we do have some generalized tooling teams whose whole job is to make sure they provide common level frameworks for everybody. However, sometimes that kind of duplication, like this is not gonna make me fans in the audience, but sometimes that duplication is the price you have to pay. So like in some ways, it's not a question of like, how do we not have this happen? It's a question of how do we manage it so it doesn't get out of control. So I like to think of it as like there's multiple different axes pulling you at any given time. So like speed is sort of like one of those things that's like counter to efficiency in a lot of ways. Like if you want your team to move really fast, they might cause some technical wake behind them. In my opinion, depending exactly what you're trying to do, that might be worth it. And it's a question of how do you manage that technical wake that shows up behind you. So those technical debt slides I showed you before are real. Like these are real pieces of code in open source software today of like real technical debt that people are complaining about. And I will say that, you know, the reason we started to rewrite at Twitter was to get rid of all our technical debt, but that didn't happen. We instead had a process that we managed it. So like every team for every single quarterly planning or every single sprint cycle, like reserves a small amount of time for just technical debt management effectively. Like that's an overly bureaucratic way of saying that like, just make sure that whatever you're mining doesn't like fall apart slowly over time. So like the product guys couldn't ask for 100% of my team's time. They would ask for 90% of the team's time to make sure that someone was just trying to clean up after themselves. Like that's just gonna be an ongoing cycle in my opinion.
Just curious, because it seems to be sort of a big point of your topic. How big is a team? And when you have sort of like teams managing kind of services, you know, we talked about a little bit of technical debt and how it kind of comes into this picture. How do you make sure that you give teams enough time to manage technical debt? Or, you know, basically it's not all about completing by a deadline, but also making sure that you're minding the code as you're working towards feature lists that, you know, at some point all code will become legacy code given enough time.
Those are great questions. So I can give you some guidelines on how I think about teams. Teams are more than 3 in a lot of ways, otherwise it's just not a team in a lot of ways. It's probably less than 7 or 8 in my opinion. I try never to have teams that are sort of larger than that scope, and I try not to have teams that are smaller than that because like at some point if you're so small, unless you're in the startup mode, which is completely different, if you're that small, you just don't make forward progress. Like you're always sort of like caught in this cycle of like taking 2 steps forward, 1.5 steps back, 2 steps forward, 1.5 steps back. So you just need enough people to make have critical mass to make progress. So it's somewhere between 3 and 7 in my opinion. Over 7, you sort of get into weird interpersonal dynamics that I usually try to stay clear of on my teams. But the question of like how do you make sure that you reserve time really comes down to just having the right personalities sort of manage it in a lot of ways. So it's not, I don't like having architects per se on my teams, but I want to have people who have a similar definition of done that I do. So like done isn't launching. Done is 2 weeks after launching when the pager hasn't gone off for a long time, right? So like trying to figure out what that definition of done really is, because that will affect the way you estimate, affects the way all these other things play out of just how do you manage work in a lot of ways. So one of the things I've always told product managers that work with me is like, you're never going to get 100% of my team. Some weeks you might get 50, some weeks you might get 90, but almost for sure you're never going to get 100. This is compounded by the fact that most teams can't estimate, so I need some slack anyway. But so you just have to realize that you're not going to spend all your time making forward progress, and a lot of your time is laying foundation to move forward faster in some ways.
Do you ever have the case where the products for a given team, there's like two very small products, so you give them to the same team?
Yep.
Or would you divide that still? And if you do that, how do you handle that?
Yeah, so I'm a big fan of single product, single teams in a lot of ways, because I just think that it's a question of focus. Like, I want my teams, I want my org waking up and thinking about the one thing they have to nail in order to get the job done. And I think that once you're trying to balance, you're always going to get caught in, what's the phrase? It's like stealing from Peter to pay for Paul or something like that. So you're always going to get stuck in those kind of debates. And like, in my experience, those debates end up taking longer than actually getting the job done, of just like, who's actually working on blah, 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 blah. So I much rather try to have distinct owners in a lot of ways. It's just like, you own the following thing, you own the following thing. It also allows you to rally your team better, in my opinion. It's just like, you guys are going to kill this one thing and tie it to the business and things like that. So I really try to get separation in a lot of things. And I think it just, again, this also comes down to just like how I manage my time in a lot of ways. Like, I try not to do more than like one big thing a day. That sounds funny, but what I really mean is like, everyone's job at Twitter or Uber is recruiting in some way, and I try not to make recruiting be one of the things I do every day. I try to like partition it, so like on Monday is my recruiting day, on Tuesday is my blah, blah, blah day. So I try to encourage the exact same thing on my team, of just like really have these strict firewalls of how we manage our time and how we manage ownership, because then you can get things done faster. I mean, everyone says like multitasking is bad, right? And it turns out to be true, especially on engineering teams. Like, code context switching is really hard for all of us.
So you mentioned that you're not a big fan of architects. I've been on a couple of programs. I feel like I'm gonna get quoted on that one. So it lends some credence to my question. So a few programs that I've been on that are supposed to be agile, we have a hard time getting started, and it feels like we should be spending some time up front doing some of those, architecture type things before, the program gets turned on day one, and we have a bunch of developers off writing code, and we end up in this ugly cycle.
Sure.
So what's your view on, how do you get started in that type of environment?
So let me first explain why I don't like architects. So like, the thing I don't like about architects is that they're usually, in the organizations that I've worked in, they're usually far disconnected from actually getting work done in a lot of ways. It's similar to asking me to architect a system. Like, I don't think I would be the right person in a lot of ways to architect a system. My job is to set up the framework by which we can make those type of decisions. And I feel like architects are just too far away from the actual code in a lot of ways, too far away from the actual problems in a lot of ways. You said agile a few times, which I like. A lot of my teams, I try to run agilely, but I must say it's like agile with a lowercase a as opposed to a capital A. And so like, what I really care about is sort of like, we figure out short time increments that we can measure progress over. And so like, when you're kickstarting the system, at some point you get into these debates of just like analysis paralysis, like, should we do this, should we do this, should we do this? But I think it really turns out, when you start breaking down the short time increments, at some point you can have the conversation of just like, guys, we're only going to spend a week or two on it. Let's just try something, and we'll learn something from that. So like, if we can't make the decision, let's at least figure out what we want to learn in the next 2 weeks that'll help us make a better decision on the next sprint cycle, for example. So whenever my teams get stuck, and I've had this a lot of times, like building a data center, for example, is a great example where you can get into analysis paralysis really easily, because like, there are 500 variables of things you want to take into account: power, number of cores, number of RAM, InfiniBand, Ethernet, et cetera, et cetera, et cetera. So what it turns out is like, what you should do, in my opinion, is build a really small test setup and start running code on it really fast, and you'll be like, and analyze the bottlenecks, and you're like, oh, InfiniBand or whatever doesn't work in our situation, we need to switch to something else. So like when you ask me like, how do we get started because we don't have any architects, my answer to that really is like, just pick any direction as long as you set up the things you want to learn and you've time bounded it, and you'll learn something that'll help you move forward on the next step.
We have time for about 2 more questions.
How do Twitter's open source projects factor into these teams? Are they considered their own products, each with their own team?
No, absolutely. So I sadly also manage the open source program at Twitter. Like the managers of the open source program all report to me. Every single one of these teams are basically, at Twitter anyway, their own company. Effectively, like they had their own headcount staffing, they had their own budget, they had their own metrics, which weren't actually tied to engineering metrics, like product metrics. For example, the tweet team, their sole job in life is to get more tweets on the system. So like there's some engineering aspects behind that, but what they really, like, I don't care how you pull this off, like whether it's a technology change or you work with the business development team to get advertisements on the air to get more people to tweet. Like, I really don't care. And I sort of treated open source amongst those projects in the same way. Only thing I asked for open source was like, there's a clear ROI for doing it. So if the tweet team wanted to open source some code, what's the reason we're doing it? It turns out most of the time you're doing it for recruiting purposes, so go do it. Like, you also own your own recruiting, so you can do whatever you want there. The trickiness when it comes to open source is release cycles get a little wonky. So like Twitter's deploying 100 times a day, and that other people might be sort of like dependent on your open source code. And Twitter, to this day, as I understand it, hasn't really solved whether you're fully developing in the open or whether you're publishing once a quarter or once a month. And I think that's the tricky thing that I don't have a good answer for, though.
Okay. Thank you very much, Raffi, for your keynote.